All right, welcome again to Number Sense Academy. And in this video, we're going to look at solving linear systems of linear equations using the method of elimination. So if you're looking for how to use substitution to solve a system of linear equations, there's a video on that. This one we focus entirely on using elimination. So the question is, when do you use the elimination method? So what I've established is that if you can get at least one of the two variables, one of the two variables to stand by itself, then go with substitution. Go with substitution. If that's not the case, then go with elimination. As with substitution, the goal is to get an equation that has only one variable in the equation, and then once we solve for that variable, we could then replace the value that we get into one of the other equations, one of the existing equations, and then we could solve for the other variable. The difference with elimination and substitution is that when you use substitution, you typically get a longer equation. When you do elimination, you get an equation that has the same number of terms right away. So with substitution, you're going to have those extra terms. You're going to have an extra constant. You're going to have an extra term with one of the variables, either x or y, because you're going to multiply by what x is equal to or what y is equal to. So that distribution is going to automatically create two more terms. So now you have four terms on one side equals something, or yes, maybe three, depending on how the equation is set up. But with elimination, the max number of terms you'll have in your equation is 3, because you're actually getting rid of one of them. So that's just something to keep in mind. So what I'm going to do here, I'm just going to jump into some examples right away to demonstrate elimination. And one thing you'll realize is that sometimes there may be a choice to use elimination or substitution. Okay, you just have to be a little bit nifty and understand what you're doing to pick. The idea is for you to be efficient, for you to be quick, for you to get to the solution as quick as possible. So let's start with this example. Suppose I have x plus y equals 1. Then I have x minus y equals 7. So based on what I've said about substitution, we know that I can easily rewrite any of these equations for x or y. And then I could just use substitution. But that's not what we're doing. In this case, we're going to use elimination, because rather than creating an extra term, we're going to eliminate a term, and you'll see how fast we'll get to our answer. So again, we're going to go back to numbering our equations. So this is equation 1, equation 2. And if you've already watched the video on substitution, you know what I mean. If not, we label the equations, and then we start jotting down or writing down all the instructions that we go through to solve our question. So I want you to have a look at the coefficient in front of all of these terms. They each have a coefficient in front of them. So for this x, there's a 1. For this x, there's a 1. For this y, there's a 1. And for this y, there's a negative 1. So what I could do, the way that we do elimination, I'll just do this quick on the side. What we do, we're going to treat each equation as a term, so to speak, and we're going to add these equations together. So if I have, you know, I'm going to kind of just ignore the values or the variables. I'm just going to focus on the coefficients. So for equation 1, there's a 1 plus 1 equals 1, right? We're ignoring the variables. And then for equation 2, I have a 1 minus 1 equals 7. So if I want to get rid of these two equations, or these two values, since they're both positive, I'm going to subtract. Okay, so 1 minus 1 is going to give me 0. And then anything that's 0 times anything is going to be 0, and I never have to include it in the equation. With that said, if I'm doing 1 minus 1 for these terms, then I have to do positive 1 minus 1 for these terms. So it's going to be 1 minus minus 1 for these terms. And then here it's going to be 1 minus 7 for these terms. All right. Now, here's the other option. I know that because I see a plus 1 here and a minus 1, I know that 1 plus negative 1 is equal to 0. So now this term would be gone if I add them together. With that said, I would then have to do the exact same thing for all the other terms. So this would be 1 plus 1, and this would be 1 plus 7. Another thing that I could do, and this might pop up sometime, is if I'm really keen on, I want to just add a positive value and a negative value, I could also make equation 2 make the value, the first term in equation 2 negative by multiplying equation 2 by negative 1, and then I'll have 1 plus minus 1 that will equal 0. And hopefully I'll have an example in my list of examples to make this a little apparent. If not, I'll make sure one of these get into the video. All right, so here's what I'm going to do. Because I'm going to actually do both of these methods just so we see. Like I'm going to subtract the x's, and I'm going to add the y's, because this is a pretty easy example to work with. So let's go. So what I'm going to do, I'm going to add 1 and 2. This is telling me that I'm adding equation 1 and equation 2. So what that means, I'm going to write it as a sum, just like how I would if I was adding other values. So I'm going to put a plus sign here, put plus minus y equals 7, and I'm going to create like the adding bar so I could get my result. So I know that 1x plus 1x gives me 2x. 1y plus minus y gives me 0y. I could write it, right? So I'm going to put, because I know they're gone, I'm just going to leave it alone, right? And then I have 1 plus 7 equals 8. And now I have 2x is equal to 8. I'm going to divide both sides by 2. So 2x over 2 equals 8 over 2. And then I have x is equal to 4. All right, and because x is equal to 4, now I'm going to sub that into any one of these equations. So I'm going to sub x equals 4 in equation 2. And what I have is, and I just picked any equation, so I'm going to have 4 minus y equals 7. So negative y equals 7 minus 4. Negative y equals 3, and this is getting a little tight. So let me just write it here. Negative y equals 3, and y is equal to negative 3. So my solution, therefore, my solution for x and y is 4 and negative 3. So now I'm going to quickly just show what would happen if I chose to subtract 1 and 2. So if I subtract, so my instruction, I'm ignoring these for now. I'm going back to the beginning. I'm going to subtract 1 and 2. So what does that look like? So now I have x plus y is equal to 1 minus x minus y equals 7. And I'm putting that minus sign to remind me that I'm subtracting, right? So I have x minus x, these cancel out, and then I have y minus y. So y minus y, there's two negatives there, so it becomes plus y or plus 2y, so I get 2y equals, remember it's minus, right? So 1 minus 7 is minus 6. So now I divide both sides by 2. I end up with y is equal to negative 3. No surprise there. That's what I got right here. And then I'm going to sub y equals negative 3 in equation 1. Just pick one. And I have x plus minus y, which is the same as, so plus negative 3 equals 1. So this is x minus 3 equals 1. So I have x is equal to 3 plus 1. X is equal to 4. And again, no surprise. We already got that from the beginning. X is equal to 4. So you see how both of those worked out. Okay, so you just have to do a bit of finessing to figure out what would make sense to do. All right, so let's look at another example. And this one I have x minus 3y equals 2. And then I have 4x minus 3y equals negative 10. And again, I'm going to label these. So equation 1, equation 2. So right away, you probably see the x standing by itself. Great. Yes, I could isolate for x, then use substitution. But remember, whenever you use substitution, you're creating an extra term. Whenever you use elimination, you're getting rid of a term. So you quickly get down to just 2 terms. Yeah, I think in the beginning I was saying 3 terms, but really and truly end up with 2 terms. So right away, I see a negative 3y and a negative 3y. Those are exact like terms. I could just get rid of those. How do I make a negative replace a negative? Well, if you subtract negative 3 minus 3y, it becomes, so negative 3y minus 3y becomes negative 3y plus 3y, and that's equal to 0. So that's how we get rid of it. So my instruction there, I'm going to subtract 1 and 2. All right, so then I set up myself. So I have x minus 3y equals 2, and I have 4x minus 3y equals negative 10. And I'm going to put a minus sign just to remind myself that I am subtracting and I don't make mistake and switch it up halfway through. So x minus 4x gives me a negative 3x. The negative 3y's cancel out when I subtract. And then I have 2 minus 10. So 2 minus 10 equals 2 plus 10, which is 12. Not a bad idea to just kind of keep some side notes to what you're doing so you don't have to do a lot of mental math. I'm anti-mental math because mental math could mess you up. Just write down what you're doing so that you don't forget. One little mistake early in the equation carries through to the very end, and it might be hard to spot because everything else looks good, but it's just that one little mistake that you made early. So my tip, avoid mental math, keep track of what you're actually writing so that you don't forget and make the mistake. So this becomes 12. All right, so I have negative 3x. We're going to divide everything by negative 3. And I get x is equal to negative 4. And now I'm going to sub x equals negative 4. In the equation, that's easier to work with. So I'm going to sub it into 1. Right? Because x is by itself in the equation. To have this 4x, don't want to get involved with that. Just deal with this 1x. And so what I end up with is negative 4 minus 3y equals 2. So I have negative 3y equals, this is going to be, the negative 4 goes to the other side, becomes positive 4. I know I say keep track of what you're doing, but that's a simple mental math. So let's go, actually, you know what? Let's not be a hypocrite. 2 plus 4, negative 3y equals 6. And then divide, so negative 3y divided by negative 3 equals 6, divided by negative 3. And I end up with y is equal to negative 2. Therefore, the solution to the system, x and y, is equal to negative 4 and negative 2. All right? And we could do a quick check. I'm going to sub these values into equation 1. So sub x equals negative 4 and y equals negative 2 in equation 1. And I end up with negative 4 minus 3 times negative 2 is equal to 2. Let's see if that's true. Negative 4 plus 6. Negative 4 plus 6 is 2. 2 is equal to 2. So those are a solution to these lines. And if you do that same check for equation 2, you will get that. You'll get negative 10 on one side and negative 10 on the other side. And it works. Excellent. All right. Next question. So we have 12y is equal to 5x plus 16. And then we have 6x plus 10y equals to 54. So, again, I'm going to label them right away. And then I'm going to do some rearranging. So, and I'm going to keep, it's not a big deal, but I'm just going to do it anyways, because I said to keep track of what you're doing. So, I'm going to reorder equation 1. Just telling myself that. I'm going to reorder equation 1, so I'm writing it down. So what does this mean? That I'm going to end up with equation 1 becomes, and I'm putting it in order just like how it looks in equation 2. So I have 5x. It's going to be 5x, right, minus 12y equals negative 16. And if you want to see how we get that, I'll just do it over here quickly. So I have 12y equals 5x plus 16. So I'm going to leave the 5x where it is. I'm going to bring the 12y over to where the 5x is. I get negative 12y. I'm going to move the 16 to the other side, so that becomes negative 16. And then I just, since it's an equation, and I could write it, I could change up the order, just as long as I keep the terms that's on, the left side and the right side the same. Then I'm going to end up with 5x minus 12y equals negative 16. And I just do that so it lines up with my other equation, which is 6x plus 10y equals 54. All right, so what's going on here? I have 5x and 6x. They don't really have anything in common. Then I have negative 12y and 10y, right? I'm not trying to get rid of, I should have mentioned this before, and it's a good time to mention it. We're not trying to get rid of the constants. We want to get rid of the terms with variables. Okay, getting rid of the constants is not valuable at all. We're still going to have these terms with variables for which we don't know, with values for which we don't know. I'm trying to get rid of the terms with variables in front of them. So there's two things I can do. The first thing I can do, I got to relabel these. So this becomes equation 3, and this still remains as equation 2. And again, not trying to put so much emphasis on this. You don't have to call this equation 3 and equation 2. You could just, since this is the exact same thing as equation 1, you could just call it equation 1, right? But trying to build some form of consistency in what I'm doing. Okay, so the first thing that I would recommend is what terms are we comfortable with working in? So if we're going to deal with the x's, then basically we need to make sure that the coefficients are equal so I could get rid of them. The coefficients have to be equal so we could get rid of them. And if they're equal, and what I mean by equal, like you could either add them or subtract them. So if one's negative, one's positive, then you add them. If they're both negative, you subtract them. If they're both positive, you subtract them. So what I would recommend for this, because I'm already dealing with these big numbers, if I'm going to make the x's equal, that means the only way this works is if it's 30x for both. So to make 5x 30x, I have to multiply by 6. But I have to multiply negative 12 by 6, and I have to multiply negative 16 by 6. To make 6x 30x, I have to multiply by 5 here. I have to multiply 10y by 5, and I have to multiply 54 by 5. Okay, so now I have, that'll be 220. Those are, or 270. Big numbers. What I could do, to save myself a bit of work, is I can reduce equation 2 to a lower term by dividing these coefficients by 2, because they're all even numbers. And what that will do now, instead of having to multiply by 6 here in equation 3 and then by 5 in equation 2, I would only have to multiply by 3 because I could use 15. If I divide 6 by 2, I'm going to end up with 3. So now I need to find a number for 15 and 3. And I'll have smaller numbers to work with. All right? I could also, and then I'm going to not deal with this negative 12 and 10. So let's do that. So what I'm going to do is I'm going to divide equation 2 by 2. So notice how I put my equation 2 label in a circle. So now I know that is the equation because now I'm dividing by a real number 2. I'm not dividing 2 by 2 because I might make a mistake and just do this. And I get 1 and now I'm stuck. I don't know what to do next. But if I write this, then I know that this doesn't mean anything because 2 is a label and this first 2 is a label and this is a real number. All right, so let's do that. So if I have 6x, I'm going to divide that by 2. And I have 10y, I'm going to divide that by 2. And I have 54, I'm going to divide that by 2. So I end up with 3x plus 5y equals 27. And I'm going to call this equation 4. This is equation 4. Okay. Now I'm going to keep my notes together. So I'm going to have 5x minus 12y equals negative 16. And then I have 3x plus 5y equals 27. Okay, and now I'm going to make, and I know that this is equation 3, this is equation 4. So now I'm going to make the x coefficients equal. And that rule is going to be, and I'm going to write down both rules. So I'm going to multiply equation 3 by 3. And I'm also going to multiply equation 4 by 5. Okay, you could have said multiply equation 3 by 3, then do the multiplication. And then you, after that, you relabel it, and then you say multiply equation 4 by 5, and then do the multiplication and relabel it, and then write them together. But it's all good. So what I have is I'm going to have 5x times 3. All right, and I'm going to have, actually, I'm going to write it this way. And you could write this however way you want. So if I have 5x minus 12y equals negative 16, and I have 3x plus 5y equals 27. So I'm going to multiply 5x by, so equation 3 is getting multiplied by 3. So this is times 3, times 3, and times 3. And this is times 5, times 5, and times 5. Hopefully you're not confusing yourself and thinking this is like 3 to the exponent 5 or something. These are just labels, and we have to be very careful with those. So 5 times 3 is, let me use a different color. 5 times 3, and we're just multiplying the coefficients, 15x, and I have minus 36y is equal to negative 48. And then for the bottom, I have 15x plus 25y equals 5 times 27. 10 times 27 is 270, so 5 times 27 is 135. All right, and then now I'm going to get rid of the x is. So I'm going to subtract, because I have two positive coefficients. These are two positive coefficients. So I'm going to subtract them. So my rule or my instruction is going to be subtract. Actually, before I get there, I forgot to label these. So I'm going to call them 5 and 6. So I'm going to subtract 5 and 6. Okay, I need to clear some space here so I could work. So let me get rid of these. And I could, yeah, I'm gonna put it, okay, so 5 and 6. So what I have is, I'm gonna write it down, 15x minus 36y is equal to negative 48. Grab my calculator because I know I can't do this mental math. I'm going to put a minus sign, so I have 15x plus 25y equals 135. So I'm minusing. So these cancel, I know that. And then I have negative 36. And then I'm going to minus 25. So that should be negative 61. So I have negative 61y is equal to negative 48 minus 135. And I have negative 183. And I already see that this works out. So I'm going to bring my work up here. And now what I have is negative 61y equals to negative 183. I'm going to divide both sides by negative 61. and I know that y is equal to 3. All right. So now I could sub y into any of the previous equations. I could sub it into equation 5, equation 6, equation 3, equation 4, equation 2, equation 1, whatever one I want. I could sub it there. So where am I going to do this? I'm going to sub it into equation 2. So sub y equals 3 in equation 2. So I have 6x plus 10 times 2 equals 54. 6x plus 20 equals 54. No, not 10 times 2, 10 times 3. What am I doing? That's how you make mistakes that mess up the whole deal. 10 times 3, so 6x plus 30. And the only reason I caught that because I'm like, wait a minute, 54 minus 20 is 34. 6 doesn't go into 34. But I know 54 minus 30 is 24, and 6 does go into 24. So I end up with 6x equals 54 minus 30. 6x is equal to 24. Divide both sides by 6. X is equal to 4. So because I run out of room over here, I'm going to write my solution in big numbers. Therefore, x and y is 4 and 3. Yep. A lot of work, a lot of thinking, but you just have to take your time and understand what you're working with, and then just kind of plot your way forward a little bit. Okay? That's the way you go about this. So let's look at another question that's going to take some energy to do. So we have 1.5x plus 0.8y equals 1.2. And then I have 0.7x plus 1.2y equals negative 4.4. And I have equation 1 and 2. All right, so if you remember, you might remember this from the video, or if you haven't, we did a video on just understanding the solutions of linear systems. I remember touching on this. So, or maybe it was a different video, the one on substitution. Nonetheless, it's there. Check them out. There's 2 videos on solving for linear systems, substitution, and one that gives you an overview. We talk about this. Whenever you have decimals, you want to raise to a higher term. You want all these values to be whole numbers. And how do you know what to multiply by? Well, find the decimal or find the number that has the most amount of decimals and figure what you need to multiply that by to make it a whole number. And then every other decimal in that equation, only that equation, every other decimal in that equation needs to multiply by that same number. Just within that equation, because each equation is going to have its own characteristics, and you have to figure it out for that. So you don't raise each equation by the same factor. You just need to raise the terms, all the terms in a specific equation by the same factor to make every one of them a whole number, starting with the one that has the most decimal places. Okay, just by looking at this, they all have 1 decimal place. That means I only need to multiply by 10 to make them whole numbers. And by the way, I could already look at this. This might be a long equation. It might be a long one to solve. So here we go. I'm going to multiply 1 by 10. And I'm also going to multiply 2 by 10. Okay? And if you're not comfortable, just use your calculator. So I'm going to tell you what those are. When I multiply by 10, that means I'm moving the decimal to the front. Okay, and I'm going to do that for all of these. So I end up with 15x plus 8y, not 0, 8y, 8y equals 12. Then I have 7x, not 0, 7x, 7x plus 12y equals negative 44. And these are my two new equations, 3 and 4. All right, so looking through these, I'm looking here, I'm looking here, I'm looking here. None, 8 and 12 are even, 15 is not, so I can't divide, I can't reduce it. I have a 7 and 12 and 44. They all have nothing in common, so I can't reduce that. 15 and 7, yeah, I don't know how those are going to collide. I'm going to need some big number to get them to be equal, so I'd have to multiply 15 times 7 and then 7 times 15. That means I'm going to have to multiply negative 44 by 15. I don't want to do that. However, if I look in 8 and y, right away I know that they have a common multiple. 8, if I multiply 8 times 1, I get 8 times 2, I get 16, times 3, I get 24, times 4, I get 32, right? 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. Wait a minute, 24 and 24. That works. And the biggest I have to multiply by is 3. It's good enough for me. So now we're going to multiply equation 3, because we're going to work with the y's. And we're going to multiply that by 3. And then we're going to multiply equation 4 by 2. Because 12 times 2 is 24. 8 times 3 is 24. So let me write those equations out, then we're going to just show our operation. So I have 15x plus 8y equals 12. Then I have 7x plus 12y equals negative 44. So remember, I'm multiplying equation 3 by 3. So times 3 times 3 times 3. And I'm multiplying equation 4 by 2. So by 2 times 2 times 2. And what do I end up with? I'm just going to write it at the top. I'm running out of real estate. So 15 times 3 is 45x. 8 times 3 is 24y. And then 12 times 3 is 36. Then 7 times 2 is 14, so I have 14x. 12 times 2 is 24, so I have 24y, so that's pluses. And then 2 times negative 44 is negative 88. One thing I'm going to say that I forgot to say. You might have seen this 1.2 and this 1.2y. Do not touch them. They're not the same. Okay, this 1.2 will never be anything but 1.2. This 1.2y is 1.2 multiplied by whatever y is, which could be any number. All right, so do not think that you could just move these around. You have to keep the y in mind. This is what makes you decide what to do, either the y or the x. Thought I'd point that out. All right, so now that we have those two equations, and I see the 24s. What I'm going to do is I'm going to subtract, right? To make two positives disappear, I subtract them. So I'm going to subtract, and I forgot to label them, subtract 5 and 6. All right, so I have 45x plus 24y equals 36 minus 14x plus 24y equals negative 88. Okay, so 45x minus 14x, that gives me 31x. Okay, Yeah, so it's 45 minus 14 because they're both positive. Then I have 24 minus 24, that's going to be 0. And then I have 36 minus negative 88. So that's 36 plus 88. Right? 36 minus negative 88 is 36 plus 88. And that's actually 124. And then I'm going to divide both sides by 31. And lo and behold, x is equal to 3. Okay, and now I'm going to sub x equals 3 in the easiest equation. Okay, at this point, I would say stay away from the decimals. Don't want to fall into that trap. Just deal with the whole numbers. So, which one looks the best? They all look terrible, but I'm going to avoid this big negative 44. I'm just going to go with the number where everything is, or the equation where everything is positive. So I'm going to sub it into 3. So I have 15 times 3 plus 8y equals 12. So I have 45 plus 8y equals 12. I have 8y equals 12 minus 45. Okay. See? Another mistake. You probably spotted that right away because 124 divided by 31 is not 4. Or it is 4. It's not 3. So, wrong. So this is 15 times 4, which is 60. 12 minus 60 is 48. So 8y is equal to 48. I'm going to squeeze that right here. So I have 8y equals 48. Divide by 8. Divide by 8. Y is equal to 6. So now, therefore, the solution, x and y, is 4, 6. And everybody's good. Everybody's happy. All right. So I'm going to do one final example and then we'll wrap this up. In this example, we have 5 over 6x plus 3 over 8y equals negative 1. Then we have 2 over 3x minus 3/4 y equals negative 5. And I have equation 1, equation 2. All right, we have fractions like decimals. We want to get rid of fractions and create whole numbers. Right? So what we want to figure out, we need to get rid of this 6 and this 8 at the same time. Then when we're done that, we want to get rid of this 3 and this 4 at the same time. We have to operate with these equations independently. Right? So what I need to figure out is what number can I use to get rid of 8 and 6. So I'm just going to, I like building this little chart. So I have 6 and 8. So I'm going to multiply by 1, by 2, by 3, by 4, by 5, and see where it gets me. So 6 times 1 is 6, 12, 18, 24, 30. Then I have 8 times 1 is 8, then 16, then 24, 32, 40. All right, and lo and behold, I see I have a 24 here, and I apologize if you can't see it really well, and a 24 here. So I multiplied 6 by 4 to get 24, and I multiplied 8 by 3 to get 24. Actually, that's irrelevant. I just need to know what number works for both. I don't need the multiple. I just need the lowest common multiple. Okay, so what I already know is that I'm going to be multiplying, not multiplying, just multiply I'm going to multiply equation 1 by 24. That's what's going to work. I'm going to do the exact same exercise for 3 and 4. You probably already know what works. So 3 times 1 is 3, 6, 9, 12. And then 4 times 1 is going to be 4, 8, 12, 16. And I already spotted the 12s. So I'm going to take the 12. So now I'm going to multiply equation 2 by 12. Okay, let's write that out. So the way I'd write that out, I'd write it differently from how I would multiply, how I would do the previous examples. So I'm going to put the 24 out in front. I'm going to have 24 times 5 over 6 x plus 12 times 3 over 8 y equals to 12 times negative 1. And I'm going to just do that math real quick. So here's the math that you're doing. You're going to take 24 multiplied by 5 and divide it by 6. And if you're not comfortable doing that in your head, then just plug it in your calculator in the exact order. 24 times 5 divided by 6. And that gives you 20. So I have 20x. Then I have 12 times 3 divided by 8. What was I thinking? Man. Sorry, y'all. It's 24. Everything here gets multiplied by 24. If you're watching this and you're frustrated, I apologize. But it's supposed to be 24. So it's 24 times 3 divided by 8. And that should be 9. So I have 9y. And then 24 times negative 1 equals to negative 24. So now I go to the next equation, which is multiply equation 2 by 12, and I clearly mix them both up. So I have 12 times 2 over 3x minus minus 12 times 3 over 4y. And notice how I squeeze the 12 in front of or behind this minus sign, right? If you're not comfortable with brackets and parentheses, that might be something to look at, but you should be comfortable with this. I could have put plus 12 and then keep the minus 3 in the brackets, but I just chose to keep it out front because I know at the end I'm still going to be minusing. And then I'm going to go 12 times negative 5. So 12 times 2 divided by 3 is 8x minus 12 times 3 divided by 4 is 9y. And then 12 times negative 5 is negative 60. So, and you know what? This equation kind of worked out for us nicely. So I have equation. I'm going to write our new equations up top and then label them. So I have 20x plus 9y equals negative 24. And then I have 8x minus 9y equals negative 60. And look at this. I have two 9y's that I could work with. And they're in perfect shape. One's already positive, the other one's negative. So I just have to add them. So this is my equation 3. This is my equation 4. So let's go to work. I'm going to add equation 3 and 4. So I have 20x plus 9y equals negative 24. Then I have 8x minus 9y equals negative 60. And I'm adding them. So 20x plus 8x, that's 28x's. Net 9 plus minus 9 is 0. Don't really care what it is. then negative 24 plus, or negative 24, I feel like I made a mistake somewhere, hopefully not. Negative 24 minus 60. There's a mistake. I'm trying to subtract them. So it's negative 24 plus minus 60. So let's see what that is. Negative 24 minus 60 is negative 84. Negative 84. Trying to make sure I didn't make a mistake. So negative 84. Yep, and we're good. So 28x divided by 28 equals negative 84 divided by 28, and x is equal to negative 3. So we didn't make a mistake. Yes. Well, make another mistake. Let me use up the space for some good. And so now I'm going to sub x equals negative 3 into an equation I don't want it, that's easy to work with. And I'm going to sub it into equation, I have x. Let's sub it into equation 4. So I have 8 times negative 3 minus 9y, that's x, equals negative 60. So I have negative 24 minus 9y equals negative 60. Negative 9y equals negative 60 plus 24. So negative 9y is equal to negative 36. So let me just drag this up here. So negative 9y is equal to negative 36. Divide both sides by negative 9, and I get y is equal to 4. So ladies and gentlemen, my solution, x and y, is x equals negative 3 and y equals 4. So negative 3 and 4. And those are some examples of how you can use elimination to solve systems of linear equations. I must say that this does take a lot of practice. Substitution is easier, even though it does produce an extra term. If it's feasible, do it. You might have to be comfortable with fractions and decimals if you want to use substitution. Remember, my recommendation was only use substitution is after you isolate for one variable. Everything on the other side is nice and clean. No fractions, no decimals. Then it's easy to use substitution. If not, you're going to have to incorporate your fraction skills and manipulating decimals. Use elimination when you don't have that option. But as you can see from the examples that we did, some of these questions or some of the work that we have to do is pretty long, it's pretty tedious. But you really have to take your time and always be checking that you are doing the right thing. Minimize the mental math. As you can see, I made a ton of mistakes, and it's easy to make a ton of mistakes. So minimize the mental math and keep things written down and just be attentive to what you're doing. Thank you.